Hey guys, it's Miss Hybert. Ready for a quick math lesson today? Great. So today we're just continuing our lesson 7-9, and that's on Math Journal page 253. So last time we talked about square numbers, and we talked about rectangular numbers. And then today we're going to talk about triangular numbers. Okay, so triangular numbers are numbers that are the sum of consecutive counting numbers. Okay, so let's look at that one more time really slowly. So the sum, what does sum mean? Sum means to add, you're right. And then consecutive, what does consecutive mean? Yeah, like we learned about that last time with rectangular numbers. Consecutive means in order, right? So like 1, 2, 3, that's counting in consecutive order, right? So triangular numbers are numbers that are the sum of consecutive counting numbers. For example, the triangular number 3 is the sum of 1 plus 2. Okay, and the triangular number 6 is the sum of 1 plus 2 plus 3. So let's think about that. When you add together 1 plus 2 plus 3, you're going to get 6. Just like when you add together 1 plus 2, you're going to get 3. Now, this is going to make a lot more sense when we model it out. You're going to see that triangular shape actually take form. So let's take a look at our chart here. Problem A says continue the patterns in the table below to find a connection between triangular numbers and rectangular numbers. Okay, so our table here, we've got our triangular number. We've got 1, 3, and 6. We know those are triangular numbers. And then we've got our rectangular numbers. I remember these well from last time. 2, 6, and 12. Our table also shows a model for the triangular numbers. I've got 1 dot for 1, 3 dots for 3, 6 dots for 6. Okay, just like if we see our rectangular numbers here, the array, right, that we worked with the last time, it's like a model for these rectangular numbers. 2 dots for 2, 6 dots for 6, 12 dots for 12. Now, since we know a lot about rectangular numbers from last time, let's take a look at those because that's what I feel really familiar with since we worked so much with those last time. I know that this array is a 1 by 2 array, right? That equals 2. I also can see that this array is a 2 by 3 array, right? So 2 times 3 equals 6, okay? And I see a 3 by 4 array equals 12, right? I know this about arrays. I know that's how they work. But remember, with our triangular numbers, and right, we're trying to find a connection here. Our triangular numbers, you have to work with sums, right? With rectangular numbers, last time we worked with products, right? Products is the answer you get when you times. But this time we're working with sums, and sum is the answer that you get when you add. Yes, you're right. So how are these triangular numbers added? Is there anything that you notice? I want you to pause this video and look for a second. Take a look at the model and see if there's anything that you notice. Now, we know that from our arrays, we kind of know how they're set up that, 2 by 3 equals 6, 3 by 4. We kind of know how our arrays are set up. See if there's any way, reread your definition of a triangular number, okay? And then take a look at the model for triangular numbers and see if there's any connection, okay? So I want you to pause this video and just look for yourself first, okay? Then I'll show you what I notice. All right, go ahead and pause. All right, did you find some good stuff? Great. I'll show you what I noticed in these triangular numbers. Well, I know that it has to be the sum of consecutive counting numbers, right? So I wanted to see if I could find those consecutive counting numbers in my triangle picture model that I see here. Now, it's kind of hard to find anything in one so far, so I figured I would just move to the second triangular number of 3. I noticed that I kind of split my little dots into like rows here. Okay, and if I noticed that there was 1 dot in this row and 2 dots in this row. Then I thought, wait a minute, 1 plus 2 equals 3. And that makes like a nice little triangle shape, right? Then I looked at my other row and I said, well, okay, that makes good sense. Let's see if that works for other triangular numbers, like number 6. So I noticed in my little rows here that I had 1 dot here, 2 dots here, 3 dots here. Wait a minute, those are consecutive counting numbers, right? And if you add them together, 1 plus 2 plus 3 equals 6. And it makes a little triangle shape when you draw it out. So I'm wondering if that's going to be some kind of connection between the triangular numbers, and the rectangular numbers. We've got 2 by 3, right? 3 by 4. See how they kind of go up in consecutive order? Just like our triangular numbers here are going up in consecutive order. 1, 2, 3. So A is asking us to continue the patterns in the table below and find a connection, right? So I'm going to help you fill out the rest of this table, and then you'll have everything that you need to figure out the rest of the problems on this page. So if we continue our pattern of like kind of splitting it up into rows like this, is it going to make another triangular number? We'll know we're correct if the model that we make actually makes a triangle shape, okay? So let's take a look. We want to do 1 plus 2 plus 3, right? What do you think the next one's going to be? 1 plus 2 plus 3 plus 4. I think that's a good idea. Let's try it out and see if it makes a triangle. I'm going to kind of start just like these are started over here. Make 1 dot. Okay, then my next row, I guess, is going to have 2 dots. Okay, then 1, 2, 3 dots. Okay, so now that looks an awful lot like this one right here. So I know I'm on the right track. We want to make 1 more row, and we want that next row to have 4 dots. So 1, 2, 3, 4. Now wait a minute. It's a little crooked, but that looks like a beautiful triangle, doesn't it? Let's split it up into rows, kind of like I did on the ones before, and see if my little pattern that I noticed works. So I've got 1 in this row here, 2, then 3, then 4. Does anybody know what that equals? Well, I know 1 plus 2 plus 3 equals 6, right, from my one previously. What is 6 plus 4? Yeah, you're right. It's 10. This shape that I created makes a triangle shape, so I know I'm on the right track. The next triangular number is 10. Now, to see if there's a connection, let's look at our rectangular numbers and our triangular numbers like together, okay? And I'll show you what I mean by that. What is our first triangular number? 1. You're right. What's our first rectangular number? 2. Yeah. All right, let's look at the next one. We've got 3, and then we've got 6. Ooh, we've got 6, and then we've got 12. All right, we figured out that we have 10. let's take a look at our rectangular array here and see if there's a connection. Are you starting to catch on? Ooh, I hope so. So our first array, our next rectangular number in this table is, we're going to figure out the array 1, 2, 3, 4 by 1, 2, 3, 4, 5. So this next array is a 4 by 5 array. What does 4 times 5 equal? 20, you're right. So the next rectangular number in this table is 20. Very good. Wow, are you noticing anything here? Triangular number 10, rectangular number 20. I'm starting to notice a bit of a pattern, aren't you? Great. Well, before we move on, we've got one more section of this table to fill in. So let's go ahead and make the model for the next triangular number. So before we had 0 plus 1, right? Then we had 1 plus 2 and got 3. Then we had 1 plus 2 plus 3, we got 6. We did 1 plus 2 plus 3 plus 4, and we got 10. So now you know what we're about ready to do. We're going to do 1 plus 2 plus 3 plus 4 plus 5. You're right. Okay, we're going to have to draw a little bit small and neat to set this up, but we can do it. Start way down in the corner with your model here. I'm going to do 1, okay, then 2, 3 dots, then 4 dots, and 5 dots. I see a beautiful triangle. This looks great. It's a little crooked, but it still works, and it still shows my pattern that I've been seeing this whole time. Let me break it down for you again. So if I've split this up into little rows like I've done, I've got 1 plus 2 plus 3 plus 4 plus 5. And it makes my little triangle shape here. Now, if the last one, 1 plus 2 plus 3 plus 4 equals 10, you can take 10 and just add 5 to it. So what's 10 plus 5? 15. Good. Now, it was kind of a squeeze to get everything fit in, so be conscious of that when you're making your own model here. You're going to have to write kind of small and be very neat. Note that if you don't draw these dots carefully and methodically, that you're not going to really have a triangle shape. You're just going to have a bunch of squiggly dots. So, you know, if it helps, maybe draw the rows first. But I think if you just work carefully and go slowly and watch what you're doing, I think you'll be able to make the dots just fine. So when you saw me draw them, I hope you were drawing them in the same order that I was drawing them, because that's the way to do it easiest, to where you can line up your dots and make an actual triangle shape. Because, I mean, it's not easy. You've got to just be careful, okay? So I hope watching me do that helped you make a nice, beautiful little triangle here. Even if it's a little crooked, that's okay. All right, almost done with our table. We have one last portion to fill in, and that is our last array that we have here. Now, we could sit here and count each and every dot, but that would take too long. We don't need to do that. We can just count the edges and times it. So we've got, if we had a 4 by 5 array here, I bet the next one's going to be a 5 by 6 array. Based on our patterns, right? And based on what we know about rectangular numbers, but let's just count and be sure, right? We've got 1, 2, 3, 4, 5. Ooh. By 1, 2, 3, 4, 5, 6. Oh, good. I was right. It's a 5 by 6 array. What does 5 times 6 equal, guys? 30. You're right. So the next rectangular number in our table is 30. All right. Now, remember, part A said that we need to find a connection between triangular numbers and rectangular numbers, okay? So if you have this table filled out correctly, which you should, I have a perfect example for you right here. You're going to be able to answer the rest of these no problem, okay? Let's look one more time for that connection. Maybe some of you have already found it, but let's take a closer look, and it might be a little bit more obvious now. If you look, we had triangular number 1 and 2, 3 and 6, 6 and 12, 10 and 20, 15 and 30. B asks us, what patterns do you notice? Now, we can't really look at the model and tell a pattern right off the bat. I mean, this is a triangle, this is a rectangle, right? I'm not really seeing a ton of patterns just by looking at the models, but if I look at the numbers, I definitely notice something. What do you guys notice about these numbers? Yeah, they're half of each other, right? Each triangular number is half of the rectangular number, isn't it? Huh, very interesting. 1 is half of 2. 3 is half of 6. 6 is half of 12. 10 is half of 20. 15 is half of 30, right? Oh, good. I'm glad you guys noticed that too. That's something that you should write down for answer B. Okay, now, I don't want to say too much, but knowing that, right? Knowing that it's half, the triangular number is half of the rectangular number, right? You could answer C. The 20th rectangular number is 420. So what would be the 20th triangular number? Knowing that this is going to continue on and on and on and on, right? That the triangular number is half of the rectangular number, you could easily solve C. Then D says, draw an array to show the rectangular number 20. Divide the array with a line shown to show the connection between the rectangular number and the triangular numbers. What do they mean by that? Well, drawing a line, could you, if we know that the triangular number is half of the rectangular number, how could you draw a line to show that connection? I'm going to leave that up to you guys. You're going to have to play with that and see if you can draw a line through a rectangular number and show its triangular model. Give it a try, okay? I'm sure you guys are going to be able to figure this out on your own based on what we learned just from filling out this table, okay? So you've got plenty of space to draw here and see if you can discover the answer for that. All right, I hope this is helpful for you. I hope this gets your brain in gear and gets you on a math path to success. Okay, so guys, I miss you. I wish we were in class figuring this all out together, but thank goodness for technology and thank goodness for YouTube. So be sure to like, subscribe, leave me a comment, and have fun finishing the rest of this. All right, guys, until next time, see you later. Bye.